Welcome to Professor Russell Esposito's channel on information security. This video is just one of many video modules that are part of Professor Esposito's course on the subject. Video modules for his entire information security course are located on this channel. So remember to hit the like button as well as subscribe if you enjoy the video. Thank you for watching.
In this module, we'll look at IPsec, which is a security protocol, and its relationship to VPNs and the OSI level 7 framework we looked at in an earlier module. Let's talk about the IPsec protocol, typically used in VPNs. This is the first paragraph here. So most VPNs use IPsec, and IPsec is really not just a security protocol, it's a suite of protocols, and we'll see what they are. It really processes a group of protocols together, a suite of them. And as you can see, there are other encryption protocols that are used, or security protocols, SSL, TLS, or SSH, but primarily IPsec is the most common security protocol that's used for VPNs, for virtual private networks. So what is IPsec? It provides confidentiality, encrypts data packets to provide confidentiality. It authenticates the source or the sending participant, and it ensures data integrity as well. IP stands for Internet Protocol and Sec for security, hence the term IPsec. And in the next slides, we'll look at the actual suite of protocols and how they work together. This slide shows a nice graphic of the IPsec framework. There's a lot of boxes here for protocols, but you can see it's a framework. IPsec manages all of these protocols. But we're not going to look at all of them. We're going to sort of zero in on the ones that are most common. As you can see on the bottom right hand side, we're going to look at AES, symmetric encryption, MD5 and SHA 384 for hashing, and RSA for the asymmetric keys, and Diffie-Hellman key exchange. So we'll look at these one at a time. This is the overall picture of how the framework manages all of these encryptions protocols, but we'll look at the protocols individually, these four, at least as we go through the next slides. So IPsec manages AES on the internet. When IPsec is used in the internet, primarily and heavily in virtual private networks, it's using symmetric encryption. As we talked about earlier, AES uses symmetric, and that's for a lot of the sessions after you've authenticated, session management, and all of the transactions happening after you've authenticated are handled with symmetric single key encryption. We talked about how this symmetric key worked in an earlier video on cryptography. IPsec also includes and manages hashing, MD5 or SHA, and these are the protocols. These are one-way hashes, the numbers hashed, encrypted. A hash means there's no key, you cannot decrypt it, and it's created before the transmission by adding up all the values in the data packet, the addressing, the payload, the actual data being transmitted, and that's being recalculated on the receiving end to see if the fingerprint matches. Does the calculation match? It's like a grocery receipt. If everything's there and the total is the same, we know it has data integrity. If there's a problem, when it rehashes on the recipient's machine, and there's a difference, it means something happened, something was corrupted in the packet, and the data is resubmitted for a recalculation. So that's what the hashing we talked about earlier, and IPsec includes this as well. IPsec also includes RSA encryption, asymmetric encryption we talked about earlier. The two keys that are mathematically related, a public key to encrypt and a private key to decrypt. The private key is never used, never sent out on the internet to anyone. It's kept by the source website and by the website that's hosting these keys. And a public key is used for its customers, partners, other participants or constituents that need to use their website but need encryption as well. And we talked about that in the other module on the main module on cryptography. And last but not least is good old Diffie-Hellman, right? The key exchange protocol that starts out with, it basically allows for a key exchange over the internet without actually passing the key or the keys over the internet. So it starts out with asymmetric, creates these symmetric Diffie-Hellman keys. And if you recall in the cryptography module, we had that little color chart that showed how the colors are used and how they never share their secret key over the internet, the secret color in this case with that analogy, but the secret key. But at the end of the process, using this Diffie-Hellman key exchange, they have the same symmetric key at the end of it. And so this is also included in IPsec, this capability. All right, now that we understand the IPsec sort of suite and the framework of it, let's put it in context, okay? So remember the OSI layer? So if you look at the left-hand side of this color chart, the arrows are going down. You know, somebody's starting a communication, an email that's going to someone else. They go down the stack, the OSI-7 layers. Goes down the stack, and then there's a physical link. That physical link could be, you know, a LAN, a VLAN, you know, a virtual local area network, or a VPN through the internet. I mean, even though the internet is sort of virtual, it's still physical, right? There are still physical devices you're going through, even though it's the internet cloud. It's not really ephemeral. It's really, you know, physical items going through the internet. So you go through the physical link, that little gray arrow at the green level, the physical level, and then it goes up the stack for the recipient to review. So IPsec is really used for VPNs, and it's that physical link here would be a common use of IPsec would be a VPN between these two OSI stacks, a VPN using IPsec. And then if you look at the right-hand side, you can see what the advantages are. IPsec is transparent. It's a transparent protocol. Applications don't have to be modified. Users don't have to be trained. No software changes made to any local client. It's, you know, it's sort of a beautiful framework that just embeds all these protocols in it and allows for the secure transmission using a VPN. And the bottom right-hand side, I just put a note. There are two types of IPsec. There's transport mode and tunnel mode. Tunnel mode is more common because it encrypts everything, the header and the data portions. So it's more secure. You might hear, when you hear VPNs, you might hear transport mode or tunnel mode, just so you're aware of if it is. But I'm not, you know, it's not something we're going to drill down in detail on. But there are two modes you should be aware of. And there's one video, this IPsec video, that I think you might find interesting, but stop at about 4 minutes and 20 seconds. It gets into other details we're not focusing on in this course. So watch the video, stop after 4 minutes or so, and I hope it helps fill in some gaps you might have, or get a full understanding of IPsec and reinforce in your mind how this all works.